In this video, we'll give an intuitive introduction to our Temporal Diffusion Curve painting system and present additional examples of our paper. The diffusion phenomenon is governed by the heat equation. Here is an example in which the diffusion source is a dot. The diffusion result can be seen as the density. It can also be interpreted as the influence from a dot to the canvas. It is definitely feasible to control the entire canvas using a bunch of separate dots. Alternatively, using curves is more compatible with humans' instinct and drawing habits. Similarly, the diffusion of curves is also governed by the heat equation, where the source is the only thing changed. Using curves provides much more usability and flexibility, as curves can be adjusted into many shapes as desired. Still, the diffusion results can be interpreted as the influence from the curve to the canvas, no matter what kind of the stroke it is modeling. Additionally, the heat equation offers the ability to reproduce the temporal evolution of the diffusion from curves, making the curves ideal for interactive applications. In this paper, we propose a random method solver for the TDC diffusion using Fourier transform without spatial or temporal discretization, and integrate the TDC with the procedural stroke processing to build a real-time painting system. Here is a simple example of our system pipeline. With the input TDCs being the diffusion source, the diffusion results are efficiently calculated with our proposed TDC formulation before they are fed into the procedural stroke processing to render the final paint. Built on TDC, a new form of stroke-based vector graphics, along with the random access solver, our painting system have several merits over the traditional digital painting systems. For example, our method is resolution independent, supports straightforward editing possibilities on strokes both at runtime and afterward, and conveniently delivers various stroke effects. Compared with the former diffusion curve method, which solves the Poisson's equation using curves as the boundary conditions for color spreading, our TDC models the stroke's evolution directly, which is much more consistent with the real-life painting experience using brushes and papers. Additionally, some results of our method, including canvas texture, crossing strokes, color layers, and a temporal evolution, are not trivial to implement with diffusion curves. From now on, we'll demonstrate several painting sections using our painting system.